Hey folks, this is Rabji Hall from Fremont, California. In this video, I will try to sum up Nvidia's keynote from CES, which was today at 6:30 p.m. Pacific Standard Time. First big thing which was announced was the GPUs for gaming, because it's a consumer electronics show and they want to sort of get done with that up front. So it's the 50 series and they have 70, 70 Ti, 80 and 90. They have simplified the naming. If you go to 40 series, they have like a lot more SKUs, but in 50 series they have simplified it. It's I don't know why they have 70 Ti. They don't have 80 Ti anymore or 90 Ti, so there's no super, so it's very simple. So that's one thing. And then after that, Jensen talked about there are two more scaling laws. So actually he addressed the concern of the market that the scaling laws will result in sort of less demand for the GPUs. So he sort of killed that argument. He said, no, we need more GPUs and two more scaling laws, which are post-training scaling. Actually, he gave examples, which we have seen from likes of OpenAI and even Google. So, and then the test time scaling, and that's when you're testing your inference, and then at that point, this is where the agentic sort of AI comes into the picture. So an agent will call a model, and then they will call another model to do different things. So that's the test time scaling. So that means you will need a lot more inference. Synthetic data generation came up many times. Digital twins came up many times. After that, he went into Blackwell, and he said it's in full production. And he said every single cloud service provider has system up and running. He said there are 15 computer makers which are making these servers in different flavors. There are 200 different configs or different flavors, different cooling, x86 versus Grace CPU versus 1IU, 2IU, all like different sort of configurations, 200 different configs. The Blackwell comes in. Actually, I have seen the AWS's own servers with Blackwell chips. Of course, they had x86. Actually, they had their own CPU, not x86. So anybody can put their own CPU in it, including Intel and AMD and others, right? So that's there. Then he showed the Grace Blackwell GB200 NVLink 72 system. That was that's a long name for that sort of system. He showed this big rack. That's their own sort of flagship config, if you will. It weighs 1.5 tons. He said 600,000 parts go into it, 120 kilowatt. He said 2 miles of copper cables and all that. So he tried to showcase that it's a very complicated system, and it's an engineering sort of marvel, if you will. And he said, and an interesting part was, he said the manufacturing is being done in 45 factories. I'm sorry, I'm looking to the left because I made all these notes, summary notes, to put in the video, so I can't all remember all these things, I guess. Then Jensen focused on the inference part, and he addressed that sort of concern of the market, which he think it will take a lot more GPUs, which I actually already sort of mentioned. He talked about agentic AI. It's mainly test time scaling. He said agentic AI is mainly a test time scaling construct. I'm putting that in my words. That's what he implied, as I said earlier. And by the way, I have said this many times, it's all about libs, libraries. When programmers program, they look for the languages which have rich libraries. And their libraries can come from third parties as well. Long ago, we used to have DLLs, and there were third-party sort of vendors will cook up DLLs for certain tasks, and Excel manipulation and all kind of DLLs were cooked, and those were libs, compiled libs. But in languages, they're raw libs as well. So Nvidia has cooked up so many libs for so many verticals, for healthcare, for drug discovery, for auto, for self-driving in auto, for factory, factory mapping of digital twins, related libs. So those libs shall go into NIMS, and they actually, those libs help you cook up the NIMS, which are the microservices sort of packaging mechanism. On that note, my read is this, that the NIMS let you package all the software and all the dependencies for running a large language model on Nvidia sort of chips. So that's a packaging mechanism, NIMS, right? So microservice. And the Blackwell system is, it packages all the chips. So there's a package of hardware on one side, which is Blackwell, but on the right side, on the software side, that's NIMS. So Nemo is a digital, he said Nemo is a digital employee onboarding and training evaluation system. That Nemo and NIMS is kind of a little confusing for most people to understand. I don't want to go too much deep into that. I think I have grasped on that to a certain extent, but still need more clarifications for my own, so I can put that in sort of simpler words. He said, in many ways, IT will become HR for AI agents. So they will onboard, IT will onboard AI agents like we onboard employees these days. I think that's a little stretch, and we are nowhere near that, and I don't think we will be near that anytime soon. Not even 5-7 years, maybe 15-20 years, we will be replacing humans with these kind of systems, but nowhere near yet. And next he went into a sort of totally new territory. I think they're cooking up new models based on Llama 3. Actually, they are distilling those models, they are fine-tuning those models to come up with the domain-specific models, and they are sort of giving it as open source, and they are naming those Neotron language foundational models, they're calling it. And they are based on Llama foundational models from Facebook or Meta. So there are 3 flavors of that: Nano, Super, and Ultra. He also showed a slide of software partners, so in 4 quadrants, which you will see on the screen here, showcasing their software partners who are participating in this universal model based on Llama. So that was the next thing. And then he talked about how he sees that software is one of the main sort of use case, software creation, which we have seen that time and again. It's one of the best use cases for Gen AI. And he said 30 million software engineers are there in the world, and everybody needs this help. And if they don't use this help, then they won't be able to compete with the ones who do. And then he next, I think it was, he went into AI and cloud. He said AI is created in the cloud and for the cloud. Very catchy statement, and I believe in cloud, so I can't dispute it. Of course, there will be AI done for the data center as well, and at the edge as well, but he is overall directionally right. So then he talked about AI on top of Microsoft Windows, and he spent a few minutes there about how the Windows are optimized for AI. I think at Consumer Electronics Show, you want to talk about the personal electronics, which is PC is a personal device, just like our phones. So I think that was okay, but it was kind of people sort of glanced over it. Then he went into robotics. He said we have 3-part system for robotics. One is the trained AI, that's DGX system, and deployed AI, AGX and AMR systems, and digital twin AI system, which is combination of Cosmos and Omniverse. After AI and cloud statement, he went into the physical AI. He talked about digital twins, and he said we need the world model for physical world, and then he quickly announced the Nvidia's Cosmos, and that's what he called the world model. And there are 3 flavors again: Nano, Super, and Ultra. He calls that world foundation model, and that is trained on 20 million hours of video. That's a lot of video, 20 million hours. So the video is fed into training this model where people are doing stuff and cars are moving and factories are operating. So this computer learning sort of system is watching those videos and learning like how these things work. So here you go. It's a physical AI related universal model called World Foundation model. It's open source and it's open license and available on GitHub. Here you go. Next thing you know, that what China will do with it and some other countries will do with it. So there goes that open source sort of open discussion. Hey, we can block the chips from China, but can we block this? So it's a little confusing part there. But anyways, those are my 2 cents. And he said magic happens when you marry Cosmos with Omniverse, and that's where physics-based sort of Omniverse is a more physics-based trained system what they have. So he said every robotics system will have 3 subsystems from Nvidia: DGX for trained AI, and AGX AMR kind of approach for deployed AI, and digital twin AI using Cosmos and Omniverse. So that makes sense to me. So then he showed a slide of partners addressing $50 trillion world GDP, which is kind of physical, most of it. So he said, okay, we're going to take over the world, and it's huge. So actually, mainly he was talking about the TAM. He said TAM is huge. And he gave 3 examples of factory manufacturing and autonomous driving and robotics, sort of those 3 examples. The next thing he sort of walked into was, he said none of this will be possible without the deep learning GPU intelligence training system, DGITS, digits. It's not DIGITS, it's DGITS, deep learning GPU intelligence training system. Then he showed the new, very fresh workstation for every developer. He calls it AI supercomputer at every desk. I call it, like we have cloud in a box from all cloud providers, and this is sort of AI cloud in a box. It's a very small sort of workstation looking like a box. Here you can see this in the video, and he said it should sit on every AI developer's desk, and you can marry 2, 3 sort of together. He showed that example in the video as well, and he talked about that, like how they created it. So they actually took their Grace CPU and they created a sort of mini version of that CPU in collaboration with MediaTek, and they put that into a small Blackwell. And I think that's a big thing. I think that's huge. So this is the smallest version of the Blackwell system, which is like 1.5 tons. You have 1.5 tons system, and you have a system which is like maybe 2 iPhones or 3 iPhones put together, or maybe 4 iPhones equivalent, which is very small. We were able to see that in his hands. He was showing that. I hope that's actual sort of system, not a sample thing. Anyway, so I think that's huge. Grace CPU was created with MediaTek, he said, and Nvidia's cloud in a box is the name of that is Digit, DGIT S. So at the end, he summarized the whole sort of session. And I think that was a little rushy, but this is what he meant to say. He said that we are introducing 3 brand new Blackwell systems, in addition to the Blackwell server they launched last year, and then it's all in the news and it's under production. So one is the Thor, that's the system for the autonomous driving. The second is the Nvidia's project sort of digit system, and that's like a small workstation AI in a box for developers to bring it to their office and or building. Third one is the physical AI related world foundation model, Nvidia Cosmos. Actually, that's he called it a system, even though there is no sort of hardware involved in that. But I don't know why he called it Blackwell. So that's, I'm a bit confused what the third thing he was announcing. So please correct me if I missed anything, and I'll try to get the clarification from the folks at Nvidia. But that's it. That was the keynote. And earlier, actually, in the day, at 2 p.m. segment, 2 p.m. PST, there was a debate around how Nvidia is progressing and if they have a moat. And he's a very well-known, renowned analyst on the semiconductor side, and he covers Nvidia. He said, I wouldn't worry about the Nvidia's competition at this point, but later we might in coming few years. And he made those comments in question to, like, hey, there are all these big cloud providers and or hyperscalers have their own GPU chips, and how about that? How much of the GPU will be given to the captive workloads? Actually, that's a good term to remember. Captive workloads, actually workloads which are captive to a host, where you're hosting your a cloud provider you have gone to using their APIs and or other sort of platform as a service and whatnot. And he said that he wouldn't worry about it, because he said right now that share is from 10 to 12% of the whole GPU market, and he thinks that can go up to 20% in next 5-6 years or so. And if you have a bigger pie, and 20% of the bigger pie goes to these hyperscalers and or these cloud service providers, it's not a big deal. And I agree with him. So if the pie is bigger, then no problem. If the pie is small, then he said Nvidia is in trouble, and at the same time these cloud providers and or these other hyperscalers will be in trouble as well. So if pie is small, everybody's in trouble. If pie is big, Nvidia is a winner. So I think that was a very good segment, it's crazy. Yeah, so that was the day, the day of Nvidia, in conjunction with CES and some commentary from CNBC, and my 2 cents in between. Thanks for watching, and I will be at CES tomorrow. This is, oh my God, this is 12:37 a.m. now. I have to get ready, put my suitcase, and gather my stuff and get ready for tomorrow's trip. And I have to wake up at 5:30 to catch my 7:10 flight. And I will see you from CES floor tomorrow. Thanks for watching.